Assalamu alaikum. Welcome to the next topic. It is the heating of cables, or sometimes it's called also direct loss in the cables. So, this heating of cables is due to the power loss in the cables, which arises from the charging current flowing into the insulation resistance. I told you earlier that the more the insulation resistance of a cable, better is the cable, because when the insulation resistance is more, the charging current is less. Sorry, the leakage current is less. So when such type of current flows, it results in the power loss. That power loss is also known as dielectric power loss. This dielectric loss actually is caused by the polarization of the dielectric. The more the polarization, the more is the power loss. We can represent simply a cable by the parallel combination of R and C, where C is the capacitance of the cable and R is the insulation resistance of the cable. Now it can be depicted from the phasor diagram easily. Let us say this is this operating voltage of the cable, and in this case this is I into Ri, because I that is flowing through the resistance will be in phase with V, and this IC that is flowing through this capacitance will be leading to this voltage by 90 degrees. That is why I have shown it over here. The total current I will be the phasor sum of this IR and IC. So that will be this. So this is the power factor angle phi, and this is known as delta, which is equal to 90 minus phi. So the power, that is dielectric loss, will be equal to I square R into Ri, which can also be written as V square by R. So actually I want to derive this equation in terms of this capacitance and in terms of this delta, and I will tell you why we go for this delta. Now P is equal to V square by R, and this tan delta is equal to V by R, that is actually IR, divided by IC. IC is equal to V into omega C. So from here V by R is equal to V omega C, that's from here, V omega C into tan delta. Now P is equal to, now I can write it as equal to V into V by R. So when V by R is equal to V omega C tan of delta, that PDC, that is dielectric PDL, dielectric loss, will be equal to V square omega C into tan of delta. Or directly you can write a V square by R is equal to V square omega C tan of delta. You can multiply by simply V here. So it will be like this. This delta is known as loss angle of the dielectric, because we are using usually this formula for dielectric loss. We can this delta is already given for the cable, and capacitance can be calculated. Operating voltage is also given. So dielectric loss usually is calculated by this formula, not by this formula, because R can also be calculated, but simply this is not given in this form. It is usually given in this form. One more thing, if this delta is very small, and which is practically the case, because this delta has to be very small, so that this power loss will be small. In that case, we can approximate this formula to V square omega C into delta, because tan delta will be equal to then delta. One more important thing is that you can see it from here. This theta plus delta will be equal to 90 degrees. So theta will be equal to 90 minus delta, or cos of theta, that is the power factor, will be equal to sine of delta. So here power loss will be proportional to sine of delta as well. Thank you.